Welcome. In this video we are gonna learn about blockchain and some attacks that can be done on blockchain. My name is Adil and I will be taking parts of this video, and first we are gonna look at blockchain 101, working and the structure of a block. Blockchain 101. A blockchain is an open distributed ledger that can record transactions between two parties efficiently and in a verifiable and permanent way. It is a ledger which is open. That means all the parties can read from the ledger, and it's distributed in the sense that there is no one central copy of this ledger. It is distributed among all the computers that are part of this network, and all the communications that are happening in this blockchain network is peer-to-peer. So it is P2P ledger, P2P protocol, and the ledger is permanent in the sense that we can't destroy this ledger by deleting one single file, and all the transactions that happen in this blockchain network are tamper evident in the sense that we can check if a transaction or a block is tampered with. Next we are going to look at the working of a blockchain. First, a user adds a transaction to the transaction pool, and special nodes called miners gather the transactions to form a candidate block and tries to add it to the blockchain. And miner then finds the hash of the blockchain by finding hash of each of the transactions, and he will find it continuously until he gets a hash which is root of the Merkle tree, and he adds a nonce to this hash so that it satisfies a condition that the hash should have this much zeros, or hash should be less than a target value. Then the block is added to the blockchain. The block is broadcasted to the other peers in the network, who verify the hash and add it to their local copy, which is maintained in their computer. So as we can see, there is an initial block called the Genesis block. It might be having a hash 4x8g, and then we will have the next block in the chain which will have a hash 3lfk, and it will also have a hash of the previous block in the blockchain, which is the Genesis block in this case. So this block cannot be tampered with, and we can't add another block in between this block. Next we are going to look at the proof of work concept. Here the problem remains that who has the right to add the next block to the blockchain. This is solved by the proof of work concept. In the proof of work, a piece of data which is difficult, more costly or time consuming to produce but easy for others to verify, and which satisfies certain requirements. In this case we are using the hashing proof of work concept model, in the sense that we try to find a hash of the block which has some certain properties, such as like the hash is less than a certain value, or the hash has certain number of zeros. Producing this proof of work can be a random process with low probability, so that a lot of trial and error is required, and on an average before a valid proof of work is generated, and it is nearly impossible to achieve this proof of work without spending enough time or spending enough money on the computing resources. There is an alternative to this proof of work concept. It is called the proof of stake. Okay, next we are going to look at the structure of a block. The block header contains the metadata like previous block hash, and it also contains the Merkle tree root. So the Merkle tree root means here the transactions are stored as Merkle trees. We double hash all the transactions. Therefore, these base unit transactions form the leaf nodes, and we take pairs of such hashes and concatenate them and double hash it to form another new node. We continue this process until we get a single node, which will be the Merkle tree root. All the leaves in the tree depend on all the leaves in this tree depend on this root, and hence it is impossible to alter one leaf without changing the other leaves. So we can't change one transaction without change. We can change one transaction and change the Merkle tree root in such a way that we can tamper the block. We also have a block identifier, which is a unique identifier created by hashing the block header twice.
Next, we look at the different types of blockchain. A blockchain is said to be public if any client who wishes to be part of the network can do so. The protocols for communication to the network and the software to run a client are made publicly available. In such blockchains, the software to run a client is usually open sourced, and anybody on the internet could download them and run a client, and the communication, and since the protocols are available online, they could be part of the network. On the other hand, private blockchains are ones which are restricted to a few parties, and it is not available for anybody else to participate in the network, in the blockchain network. Like another kind of classification to blockchain happens to be of permissionless and permission blockchains. A blockchain is said to be permissionless if all participating entities are given the exact same privileges. This means that every participant in the network is allowed to do the same set of operations, and every participant gets this exact same say in any decision that is made in the network. Again, on the other hand, permission blockchain allows for different clients to be treated differently. This could be in the sense that only certain parties or certain nodes are allowed to perform certain activities, or they could have a higher say in any sort of decisions. So all the public blockchains, the blockchains like Bitcoin or Ethereum that runs the cryptocurrencies, are public permissionless blockchains in the sense that they are available for everybody and every node is treated equally. Private and permissionless blockchains, permissioned blockchains are used for internal uses within a company or a specific industry, and usually they require some sort of an authentication service to make sure that these nodes are treated differently as required. Now we look at what forks in a blockchain is. So a fork happens in a blockchain when there is two potential path forwards. So this divergence might be caused by a divergent transaction history or by a new rule that decides what transactions are valid. And a temporary fork occurs when different miners mine different blocks in a very short time interval, and this is resolved using the longest chain rule. So in this example, let's say if 1 to 4 blocks are agreed upon by the entire network, and different miner nodes are competing to mine the new block number 5. Let's say that one of blocks node A, B and C mine the block 5 which is shown here, but since the network is a peer-to-peer network and network traffic takes time, it takes some time for that information that this block, information about this block has to reach. It takes time for this information to reach every other node. It is very possible that in this meantime, one of the nodes D or FG also mine a new block 5 without the knowledge of this block 5. So right now there are two sets of nodes in this network, a node that believes this block 5 is valid and another set of node which believes that this block 5 is valid. So eventually like other nodes are either added on top of this or on top of this depending on what these nodes have come to know of. But in the end, when a node comes to know of both of these two chains, the node decides to go with the longest chain. This is the protocol that is enforced in blockchain to handle temporary forks such as these. Now there are other types of forks as well. These are called soft forks and hard forks. So a soft fork happens when by a protocol upgrade or a rule change that is backwards compatible with an older versions. For example, let's say a decrease in the block size. If for example 1 MB is the current block size and then there is a newer protocol that says 500 kilobytes is the updated block size, then this change is backward compatible, so that every block that is valid as per the new system is valid as per the old system as well, so that the nodes which were running the older software need not upgrade just to run the machines, but just to run the client, but if they have to create new blocks, then they'll have to be updated to the newer protocol. A hard fork, on the other hand, occurs by a protocol upgrade that is not backwards compatible, and this can be thought of an example where the block size is increased. For example, if the block size is increased from 1 MB to 2 MB, then not all the blocks that according to the new scheme is a valid block in the old scheme. So hard forks can be planned or contentious. The planned ones are the ones that we talked about just now, like a planned protocol upgrade. Contentious ones occurs when there is a severe disagreement within the community. So there might be disagreements on how the new rule should be framed or formulated or executed, and both the and so there is a divergent there will be two path forwards, one that follows the new rule and one that follows the old rule, and both of them exist simultaneously if there is minor support for both. That is, if there are enough participants to run the networks with both these different rules, both these exist simultaneously, they just share a common history. Now we go into the attacks of the blockchain. So a blockchain can be thought of as a form of governance of a distributed ledger. It just lays down some rules on which people can agree on what information is stored in a ledger, and the protocol facilitates this governance by means of what is known as distributed consensus mechanisms. And at the core of these consensus mechanisms, they all work by majority, at least the majority of people who are actively participating in the network. And the underlying idea is that if one has a majority over the mining network, the network that adds the new blocks to the system, then one can potentially get away with adding false blocks to the chain. So this is what is known as the 51% attack, and the 51 stands for the majority. So that if some malicious player happens to have a majority over the mining networks, then they can add malicious blocks which they want with transaction which are in their favor, and then since this works on consensus, there wouldn't be enough majority to deny it, so that blocks get added to the blockchain as a very valid block. But these attacks are not usually done to claim false things, because whenever there is a 51% majority, it's very easy to spot it, and the network is usually discredited. So people wouldn't want to believe in a network where some party has a 51% share. It wouldn't be decentralized anymore, and any decision that they want would be executed. So these kinds of attacks are usually done to discredit networks as a whole, and it's very difficult to do that in a network like a Bitcoin network, the Bitcoin network, which is very large and would require a party to possess huge resources if they wish to control the network by a 51% majority. There are other attacks as well. Being a distributed network, denial of service is a possible attack. In this type of attack, the attacker tries to spam the network with spurious traffic. It's much more difficult to perform this attack in a distributed network compared to a client server model, because there are a large number of good nodes, and in order for the whole network to fail, huge amounts of traffic will have to be generated and sent across to different nodes, which is not usually very feasible. But still, parts of the networks can be choked and maybe delayed in updates using DOS attacks. A Sybil attack is one in which the attacker pretends to be so many people at the same time. They could try to form a majority and perform a 51% attack. So since it is publicly accessible, these client software can be run by anybody on the internet. A single party could just keep creating more and more parties to form a 51% majority. But again, this is very difficult to perform on a network with a large number of nodes, because to have 51% majority on a network like the Bitcoin network would require huge amount of resources. And in the end, if a 51% attack happens and the network is just discredited, if people just find out that somebody has a majority in the network, then most of the effort goes in vain. So that is not a very probable attack in a large system such as the Bitcoin network. Now there is an attack called the Eclipse attack. In this, the attacker monopolizes connections to a single node, then the victim don't get be tricked into accepting spurious transactions. So each node in the network wouldn't be directly connected to every other node in the system. So let's say if we have a node which is connected to 3 or 4 nodes, and if someone would somehow have some control over all these 4 nodes, then we can essentially control what information reaches this victim node. So if the victim node hosts a client which has some value, then we can essentially double spend it. For example, if I fool the node to believe that I have transferred some Bitcoin to that node, maybe I could obtain some services in return or purchase something. But the other parts of the network doesn't know about this transaction, and I get to spend my Bitcoin, my cryptocurrency there as well. So it is essentially double spending happening because one node is being fed only false information, and there is no other way for this node to understand that this is spurious information that is different from the rest of the chains. Now there are attacks on cryptocurrency wallets. Technically, these are not attacks on the blockchain. These are probably attacks on web applications or services that are run along with blockchains that support cryptocurrencies. So and these could be any sort of attack that happens on a usual web application or service, and the attackers usually try to get access to key pairs or public key private key pairs which might have been stored on the wallet service, which with a weak security. If they have access to those keys, they essentially have access to all the cryptocurrency of the customers of that wallet. This still happens to be a very strong attack vector, and a lot of attacks do happen on this front. So cryptocurrency wallets attacks on these and are a big chunk of attacks in this domain, but technically they wouldn't be classified as attacks on the blockchain as it has nothing to do with the blockchain technology or the protocol as such. So that's it for this video. Thank you for watching. Bye.